Kia ora tātou, welcome to this video on permanent dipole-dipole attractions. So this is effectively if you've got a polar molecule, there's going to be permanent dipole-dipole attractions. So I've just drawn what would be a simple polar molecule here. So this could be, let's imagine it's hydrogen chloride or something like that. So we'd have the hydrogen would be the positive part of this molecule and the chloride would be the negative part of it, because the chlorine has got a greater electronegativity, so the electrons are going to spend more time around this part of the molecule than this part of the molecule, and because it's an asymmetric shape, there's no bond dipoles are going to cancel. So when we're talking about permanent dipole-dipole attractions, you would need to identify, you might be given a molecule and you need to identify what types of intermolecular forces exist between those molecules. And so you just need to have be able to look at a molecule and see relatively quickly whether or not you think it would be polar or non-polar. So that's a bit of a skill with this, is identifying polar molecules. And then we've got this, because we've got a slight positive charge here on these sides of the molecule and a slight negative charge here, we're going to have some electrostatic forces of attraction between the positive and the negative parts of the molecules. So these are permanent dipole-dipole forces of attraction. Permanent dipole-dipole attractions. In these molecules, because there's still the electron cloud, there would still be instantaneous dipole-dipole attraction as well, but there's going to be permanent dipole-dipole attractions on top of that. So let's have a look in practice what this would mean. So if we've got ethane molecules, ethane has a boiling point of negative 89 degrees, whereas ethanol has a boiling point of 78 degrees. So how can we explain the difference in boiling points between these two molecules using the knowledge that we've just got? So both of these molecules are going to experience instantaneous dipole-dipole forces of attraction between molecules. So between ethanol molecules there will still be those instantaneous forces, and then between ethane molecules there will be those forces as well. The difference is that because this is a non-polar molecule, this is not going to experience permanent dipole-dipole forces of attraction, whereas the ethanol molecules will. So because of those additional forces of attraction, it's going to require more energy to break the bonds between ethanol molecules, and so this has a higher boiling point than this. One thing I should point out, that the instantaneous dipole-dipole forces of attraction would be greater in the ethanol molecule anyway, because it's got a slightly greater molar mass, but that wouldn't be large enough to account for this difference of more than 100 degrees Celsius. So that is permanent dipole-dipole forces of attraction. In the next video we will look at hydrogen bonding.